Hi, this is Shirisha. In this project, I empirically investigate the important result presented by Levy and Goldberg 2014 skipgram with negative samplings. SGNS can be interpreted as implicitly factorizing a shifted PMI matrix. The experiment compares the representations learned by SGNs with an independently computed shifted PMI or PPMI matrix from the same corpus. In this project, we cover training SGNs from scratch on a small corpus, vocabulary size of approximately 3000 to 5000 watts, training with different numbers of negative samples, example k is equals to 1, 5, 15, reconstructing the matrix from the above learned embeddings, independently computing S ppmi w comma c is equals to max pmi w comma c minus log k comma 0. Comparing the reconstructed SGN's matrix with the shifted PMI representation, computing mean absolute error, Pearson correlation, computing statistics over the relevant non-zero entries, creating scatter plots comparing reconstructed values with shifted PMI values, studying how the agreement changes as the number of negative samples increasing. The Levy and Goldberg connection. The central relationship instigated in this experiment is MS equals to PMI W, C minus log K, where K is the number of negative samples. The SGN's objectives can therefore be connected to a factorizing shifted PMI matrix. This matrix an important theoretical connection between predicted word embeddings and count-based distributional representations. Matrix reconstruction. After SGN's training, the learned word and context matrices are used to reconstruct the implicit matrix. MCAP is equals to W context transpose W word. This reconstructed matrix is compared with the independently calculated shifted PMI values. A, po- a high Pearson correlation and low MAE indicate stronger agreement between the learned SGNS representation and the theoretically predicted shifted PMI structure. Scatter plot analysis. For each value of k, a scatter plot is generated with x-axis PMI W, C minus log k, y-axis with MCAP W, C. The plot provides a visual indication of how closely the SGN solutions follow the shifted PMI correlation relationship. The experiment also examines with whether the relationship changes as the number of negative samples increases. The effect of negative samples are k is equals to 1, 5, and 15. Increasing k changes the theoretical shift by minus log k. Therefore, changing the number of negative samples changes the target matrix that SGNC is expected to implicitly factorize. The correlation and error measurements are used to determine whether the empirical results follow the prediction. The second part of the experiment investigates an interesting question. Does good old SPD do just fine? SPD is trained directly on the SPPMI matrix and compared against SGNS using the same P9 evaluation suite. The comparison includes semantic relatedness, synonym detection, semantic analogies, syntactic analogies, 3-cos add, 3-cos merge, OOV read, whether applicable. This comparison helps determine whether the additional complexity of a predicted model such as SGNS provides a meaningful advantage over a well-designed count-based method. Thank you.